Hi, everybody. My name is Vinay Vakaria, and today I'm going to talk to you about mask detection and convolutional neural networks. So a little background here. For the better part of the year now, we've all been having to wear masks, and nothing is more egregious to me as when you go to a grocery store or anywhere and someone is wearing a mask and their big nose is hanging out. Um, I do believe this has a real world potential use case if you want to track how many people are actually accurate, wearing masks properly or not at all or improperly. And I also wanted to figure out how neural network and how they took in images, classified them. So a little bit about my data here. My data was broken up into three classes: uh, incorrect mask, with mask, and no mask. And a incorrect mask is if it does not cover the entire nose and mouth and chin area. Here's a little distribution of my data set. As you can see, the three classes are pretty evenly distributed, so they are not, there's no imbalanced classes. I did an 80-20 split, 80% training and 20% validation. Here on this page, you can see the structure of a convolutional neural network. This network actually has three layers, three convolutional layers, and then three pooling layers. And at the very left-hand side, you can see there's an input layer that receives in an image. The features are extracted and filtered. And on the right-hand side, there's a fully connected layer, and it spits out a probability of whether or not that image is incorrect, with mask, or no mask class type. Here on this page, we're going a little deeper in the convolutional layers. Now, what's happening here on the left side is we see these boxes, and each one of these is a filter. And these filters are passed through the convolutional layers. They slide through the image, and they pick up a pattern. And on the right-hand side, you can see a pattern of the mask shape that is picked out. Now, this is a high-level overview, an illustration of how this pattern recognition process works. The deeper the network, the more patterns or shapes or textures can be picked up. Now, the results of this model were actually quite surprising. I only had 18 misclassifications and accuracy of 96%. And this made me very suspicious because this model is actually very shallow, but the accuracy is very high and I had a very low number of misclassifications. So on the next page, we can look at some of the misclassifications that I have. So here you see on the left-hand side, you see an image of two people. One of them is not wearing a mask and one of them is wearing it incorrectly. And I believe the model is picking up on the individual with no mask on and it's classifying it as no mask. The second image is of a baby and it's classified as incorrect. Now, when I did some digging into my data, this was actually the only picture of a baby. So this was a really unique image and the model did not have enough training data of baby pictures to accurately predict the class type. And at the very bottom, you can see there's actually some text at the bottom of the image too, which may have thrown it off as well. And on the third image, this image was classified as no mask and it's actually worn as an incorrect mask. Now, it may have picked up on the nose texture or something like that, but this made me do some more digging into the incorrect mask class type, which we'll look on the next page. So as looking at, when I was doing some more digging on this class type, I noticed that many of the pictures had this structure to them, and you can kind of see something similar between all three of these images. And they all have this watermark, and at the bottom they all have a URL, and they have all these kinds of similar features. So it's my belief that the model is picking up on these features to classify whether or not the image is in the incorrect mask class. So my future steps, I definitely want to implement this model on a new data set, scraping data from social media. And I would like to use object detection to detect an individual's face in an image, implement transfer learning, so that way the model can predict whether or not someone's wearing a mask on that bounding box. And ultimately, I want to create a model or a web application that will take in a video, either live or recorded video, and predict whether an individual in that video is wearing a mask correctly or incorrectly. This is my tech stack that I use for this project. Thank you very much for your time.